Mecanum wheel-fitted robots, or industrial machines, can make a 180-degree turn without taking much space, whereas a normal forklift takes a lot of space and time to achieve the same task. Consider this perfect sideward movement of Mecanum wheeled machines. This would be tedious to achieve using normal wheels. Mecanum wheeled machines achieve all these crazy movements, but their wheels never tilt. Let's see how Mr. Bengt Erlend Eiland came up with this brilliant design. The brilliance of the Mecanum wheel is that it can produce a driving force at an angle of 45 degrees, even though it rolls like a normal wheel. The inspiration for the invention of Mecanum wheels may have come from these simple examples. In the first case, when you try to transmit a force, you will be able to transfer only a small amount of force because the roller is free to spin. This is similar to a freely spinning electric motor's inability to transmit any force or power. In the second case, you can easily transmit a good amount of force to the arrangement. Keep these two concepts in your mind throughout this video. The spark of genius that birthed the invention of the Mecanum wheel occurred when the inventor used a roller angle in between these two extreme cases, an angle of 45 degrees. He used many such free-to-rotate rollers throughout the periphery of the wheel. The side plates will properly hold the rollers if you make some projections on them as shown. As soon as this electric motor-powered Mecanum wheel touches the ground, a frictional force is generated at the contact point as we saw earlier. Can you predict what will happen now? Let's split this force into two directions, one along the axis of the roller and the other tangential to it. Since the roller is free to spin in this direction, the magnitude of the tangential component of force will be very small. However, in the axial direction, there will be a good force transfer. In short, the Mecanum wheel, even though it spins like a normal wheel, produces a frictional force or driving force at an angle of 45 degrees. Now, let's get into the most interesting part of this video. Design of a highly versatile car using 4 Mecanum wheels. The genius of Mr. Eiland is that he used the wheels we just saw in 2 locations only, as diagonally opposite paired wheels. For the remaining 2 wheels, he used Mecanum wheels with exact opposite orientation. Remember, we cannot get this new orientation just by flipping the old wheel. The diagonal wheels must be fabricated differently. This car will move forward, but its movement will be jerky rather than fluid. The issue is with the rollers, as you can clearly see in these animations. These roller road interferences will cause jerky movement. To solve this, Mr. Bengt Erlend Eiland chiseled off some portions of the cylinder and made the shape curved as shown, making the interaction between the ground and rollers smooth. Let's see how this forklift can achieve a perfect sideward movement. To achieve this motion, we must turn the diagonally opposite wheels in the same direction and the other wheel pair in the opposite direction. The frictional or driving force produced by all the wheels are marked here. Let's do a force analysis. As you can see, all the Y component forces get cancelled and the X component gets added up. The net result is a perfect X direction motion. Now, consider the case of all the wheels rotating in the same direction. It is quite clear that the X components of force are getting cancelled here and the Y components get added up. The net result? The car will move in Y direction. What if we keep only one pair of the wheels on? The net force will make it move diagonally. Let's explore how this car can achieve a perfect rotation with respect to its center. To achieve this, just rotate the left wheels in one direction and the right wheels in the other direction. You can see the new force pattern. Here, all the X and Y components of the forces get cancelled, resulting in a lack of translatory motion. However, these forces can produce a net torque, which will make the car spin at its center. Some more interesting rotary motions are possible if you vary the speed patterns of the wheels. Considering the complexity of Mecanum Wheels, we can't deny that the engineers behind it were creative masterminds.